everyone, I'm Lucas. I'm a full stack developer in BrainHub, and I'm very happy that I can welcome you on our first DevDuck meetup in South America. Let me give you a short introduction so that you know what we're doing here. DevDuck is organized by BrainHub, a team of passionate JavaScript professionals. We're working with tech-driven companies from around the world, and we develop their software ideas. We work with international clients spanning from Miami to Singapore, such as Paradox Interactive, National Geographic, and Beam. From very humble beginnings in 2015, only a handful of people in a small office, we've become one of the fastest growing companies in Central Europe. During that time, we've built an amazing team of 75 people located in 5 Polish cities. And recently, we've also opened our first office in Montevideo. The idea of DevDuck was born in 2016. Since that time, we've organized more than 20 events in 4 Polish cities. We wanted to share our passion for JavaScript. We wanted to gather the community of like-minded people. So during these events, we discuss topics related to JavaScript, DevOps, non-technical skills related to software development as well. Today, as you probably already know, we're going to talk about React. In BrainHub, we are doing our best to create a friendly work environment. Our employees can choose their own work hours, work remotely, enjoy productive workation, and also have meaningful influence in their projects and on the whole company's vision as well. We cultivate healthy relationships with our clients. We're not just developers for them, we're partners and consultants. If you're passionate about Node.js and React and want to join our team, feel free to visit our website, brainhub.eu/careers to learn more. If during today's presentation you have any questions, then feel free to comment in the chat. We will try to answer all of those questions. If not immediately, then there's going to be a Q&A session towards the end of the presentation. And now let us listen to Marek, who is going to tell us how we may have come up with React.js.
Hello, everyone. Thanks, Lucas, for the introduction. My name is Marek, and this is how you may have come up with React. This presentation is going to be a short exploration of the reasoning behind React, the fundamentals that made this library so popular. I personally find it very helpful to understand the thought process that leads to inventing something interesting. So I think this presentation might help you understand React as well, especially if you've been working with it for a while and never actually gave much thought into what's going on behind the scenes. In other words, it's going to be a retracing of steps that someone at Facebook took in order to come up with the library that we know and love today. So before we begin, a little word about me. You could find me at these socials. I've been a full stack developer with BrainHub for a couple of years now. I have a Twitter and GitHub, and I also write a blog about philosophy and technology and how they interact with each other. Okay. So let's begin with an example application that we will study. This is going to be a small breakfast menu. We're going to have a couple of cards that have various dishes that someone might want to order. They exist on some kind of website. We're going to receive data for this site from a backend API, and we just want to render this data in an appealing format inside of our website. This is the code for it. As you can see, it's very uncomplicated HTML. We have a container for our card. We have a couple of children elements for the details and rating, and there's some variable data here as well. You can see that every card has its title. It has some kind of description, and there's also a rating. So this is what we want to end up with, and this is the data that we're going to work with in this format. So this is going to be basically just JSON that we receive from some kind of backend API. We expect to receive this in via Ajax, so with fetch or XML HTTP request, if anybody even uses this anymore. And we want to render this sort of dynamically into the site. So the first idea that we might have, and I'm calling this the naive approach for reasons that will become apparent really quickly, we might think of something like this. First, we're going to hook into the actual HTML element that this entire thing is going to sit in. I called it container, and I'm also using the very ancient style of naming our references to direct HTML elements with $sign. We're going to target that container, and we're going to wipe the entire inner HTML of that container. And then we're going to iterate over our menu, our data that we've received from the backend API. And we're going to use a template literal to render that data inside some sort of markup. This is not really dissimilar from how you might have done this like 15 years ago in PHP. This is very similar idea, except here we're doing this client side. And finally, we're going to add that inner HTML to our template. Or rather, we're going to add the template to our inner HTML, sorry. And this is basically the what I'm calling the naive approach. This is going to work, but not very well. We use template literals to render a string directly into HTML, and this is, as you know, if you've ever worked in React and tried to use inner HTML, it's basically going to tell you not to do that. There are workarounds for it, but there are very good reasons why you don't want to use inner HTML. The biggest of them is that we don't sanitize user input. So if the user decides to input, instead of, let's say, blueberry pancakes, they're going to say angle bracket script angle bracket, they're going to basically nuke our entire website. So this is not really ideal. Also, this doesn't really scale. We can't reuse the code that we've written. We can't create components out of it because this is just HTML. We're rendering direct HTML into our website. And also, there's a slightly more pernicious issue with this, which is that inner HTML recreates the DOM tree from scratch with every render. So if we were to change this data even slightly or add anything, even the smallest thing to this template, it's going to re-render this entire thing, and that leads to things like removing event listeners and stuff like that. So this is really not a very good idea. But we have an entry point, so we can improve on it. So let's take another step and do some DOM manipulation. So we're going to do something very similar here. We're going to hook into a HTML element, and then we're going to iterate over the menu again. But this time, instead of using inner HTML, we're going to use JavaScript DOM manipulation methods. So we're going to create elements using these methods of various types. Here we're going to create a div and add a class to it. We're going to create another div and add another class to it for our details. And we're going to create the header element for our title, the paragraph element for the description, and another div for our rating. We're going to also add classes and text contents to all of them, append them to their parents, and then finally append the entire card to our container. So this is much better. The text content ensures that any stray XSS code does not get executed because anything inside the text nodes is just text. It does not get run. Building the DOM this way is much cleaner than with inner HTML because we're using actual functions instead of string-driven development. So our linter actually can catch any typos if we happen to make any. And also, this is to some extent reusable. But there is a lot of repetition, and each code block uses the same create elements and append child methods. So since we're programmers and we're generally lazy, we want to make sure that we don't have to write too much. So let's reuse code. Here, really what we're doing is we're extracting the common part into a function that I've called create element. And it's called create element because the same function that does the same thing in React is also called create element. And if you ever used React without JSX, which, by the way, that's pretty brave, this is what your JSX is going to be roughly transpiled to. There are some differences, and because there's a bit more streamlining, but this is in essence what this becomes. So since the two functions that we repeat every time is append child and create element, we're going to put in the variables, the variable contents of these methods, the parameters that get passed to them, into this create element function. So we provide it with a type, a parent, and then some kind of operation. And this operation is the variable thing that we're going to do. We're going to create the element of a given type. We're going to apply this operation to it. Basically, this is just a callback that is going to apply like classes and text contents and stuff like that. Then we append that newly created element to a parent, and then we return it. And that's really all this does. And then we do the same thing. We iterate over our menu, and then we create these elements. Now, instead of having a whole bunch of methods, we just have one for every element, and then it modifies it slightly with classes and text contents as needed. So what this does is it creates reusability, and reusability is really cool. We can wrap these elements and these components in closures and export them to different modules, and we can do arbitrary operations on the newly created element, such as including other elements. This is what we can do. We can sort of create a callback inside a callback, or rather, we can use the create element function inside another create elements function callback. I think that's English. Anyway, we can do this sort of thing, and what this allows us to do, or rather what this shows us inside the code, is that there is some sort of visual hierarchy of these elements. You can see that the bold text is going to be a child of the paragraph. So this is a little more general than what we need. So let's slightly contain this, and let's only include the parts that are actually relevant to what we need to do. If you notice that inside the operation callback that we included in this previous create element implementation, we only ever did two things. We either added classes, or more broadly, included some sort of attributes, and added some content. So really, we don't need to have a callback for this. We can just have it as data. And to have it as data, what we're doing here is changing the last parameter that was an operation. We're changing it to attributes and content. And then we iterate over the attributes, and we set them on that element. And finally, if we have some content, because it doesn't have to have content, of course, an HTML element does not need text content. It can have other HTML elements as its children. We're just going to add it if it exists. If it doesn't, then it doesn't do anything. And then it appends it to the parents and then returns that element. And this is how we would use this. We're basically telling our function to create as a div of a certain parent with certain attributes and a certain content. This increases our abstraction because we no longer think in terms of manipulating DOM nodes, but rather we think in terms of components that these nodes create. Although we lost the ability to chain multiple elements together in a visually cohesive way, and that's not really good. So let's take a look at the final form of what we want to create. This is the last. This is the last iteration of the create element function, and it's pretty big. So let's go through it again. It takes in a couple of parameters. The ones that are really important for us are the type, attributes, and children. So if you think about it, every HTML node can be described using these three parameters. Every HTML element has its type. It can be div, paragraph, a, h1, whatever. It has some sort of attributes like ID, classes, and so on. And it has some children, and the children can either be text nodes or HTML elements themselves, which have these three attributes as well. We're also including a parameter called parent here because we sort of have to attach this at some point. Since this is, we can't really create this in a vacuum, and even if we were only using these functions, we still have to attach them to the HTML root. So we need some kind of parent just for the entry point. But the rest of this is really straightforward. The only changes here really is this children parameter, which we've changed from content, because here actually we can create children that are HTML elements. So we iterate over this children array, and then if that child has a type of object, meaning in essence it's we think it's an HTML element, we're going to apply that object to this create element function recursively, and we're going to mark our outside element as its parent. But if the child is not a node, it's something else, we're just going to create a text node instead. And we're going to give it the content of that child and then append it to the parent. And this is how this is used. So as you can see, we are basically modeling the entire HTML, but instead of doing this in HTML, we're doing this in JavaScript. More precisely, we're using JavaScript object. And this is really useful. As you can see, like we're doing the same thing as before. This is the same exact structure of data as that HTML bit that we did in the very first approach in that template literal. But here it's done basically just recursively. We create our card div, and we create our children, the details of title and description, and then our rating, and then that's really it. This tree, by the way, if you were to respond to changes to this tree by diffing it with another one, so for instance, you would say have some data change, like the title of blueberry pancakes suddenly is strawberry pancakes or something like that. You could respond to these changes by instead of redrawing this entire tree, you could diff it and only respond to changes that have actually changed, not redraw it from scratch. And if you would do that, you would have basically created the virtual DOM that React uses. So let's take a little step back. If you've taken high school maths, you probably know the definition of a function, and that is a function is something that takes in some arguments and then it returns a value. Whereas what we've done is something called a functional component, which takes in some props and returns some HTML elements. And really, behind the fancy JSX syntax, which, by the way, if you look at what happens behind the scenes with Babel, is converting JSX to something similar that we've done here. Behind the clever naming of things like hooks and suspends and portals and so on, behind a really nice optimization of virtual DOM, and behind many optimizations like React Fiber or ensuring immutability of state, this is really just a function. This is what React is. It's just a function. So on that note, thank you very much. And if you have any questions, I'll be happy to take them. Łukasz is telling me that there's a bit of a lag, so I'm going to wait for a bit. All right. If there are no questions, then I'm going to give the stage back to Łukasz, and thank you very much for listening.
Thanks, Marek, and thank all of you for being with us during this historic event. I've just noticed that there is actually one question. Oh, it's a tricky one. Okay. Let's try. Let's try it. Let's try answering that question. Marek, are you with us?
I'm with you, yes. And the question is, do you think React is better than Angular? I'm not qualified to answer this question because I've never used Angular. So in my opinion, yes, but really it's just up to the PR of the people who made React.
Yeah, I'm not able to answer that question either. I've used Angular a long time ago, and now I'm focusing on React as well. So we're probably not the best people to answer that particular question. We obviously love React.
React is pretty cool.
Okay, if there are no more questions, thank you. Thank you again for being with us during our first South America DevDuck. I hope you liked it. If you did, like and subscribe, obviously. And you can follow us on social media. You can find more about upcoming DevDuck events on our page on Meetup. And also, either if you liked it or not, give us feedback. You can find the link to a really short feedback form. It's literally 1 minute to fill it. You can tell us what you want to hear on events like this in the future. Once again, thank you very much, and see you on next DevDuck.